Welcome to the Bentley Systems training course where you will learn how to generate wind loads for building structures in STAAD.Pro Connect Edition. In this first video, we're going to show you how to create the wind load definitions. STAAD.Pro has the ability to generate wind loads based on a number of different codes and reference standards, and to apply these to a variety of structure types. Pressure distributions are calculated and converted into forces, which are then applied to the structure as nodal loads. Wind definitions will be used to define the values for all of the parameters that are required to generate wind loads according to the selected design code standard. This includes parameters such as the exposure category, topographic factor, your wind to length ratio, and your natural frequency. As wind loads are developed for a structure, it is not uncommon to find the values for these parameters may vary depending upon the particular direction of wind being considered. This points out that certain amounts of prior planning can be helpful when establishing our wind loads. For our sample model in this course, it will be necessary to define the wind loads in the X and Z directions separately, since the building dimensions are different for each directions. The first step in generating your wind definitions for your sample model would be go to the Workflow Page Control area, and then you're going to select the Loading tab. Now you're going to notice that when you select the loading tab in the ribbon toolbar is also going to become active. At this point, I'm going to go ahead and pull down my definitions area and my load case details. Now in STAAD.Pro Connect Edition, we're going to first start by creating our wind definitions. If I go up to my loading tab in the ribbon toolbar, I'm going to find my Define Load Systems area. These include all the different load types that will allow you to define some code parameters in order to instruct STAAD.Pro to calculate the magnitudes of loads for you. We're going to start with our first item here, which is the wind definition. Here I'm going to start with type number 1, and I'm going to create my first wind definition. This will be for my windward wall when wind is acting on the structure in the X direction. Once we're done, we'll go ahead and click Add, and you can see a new wind definition has been added. And we can repeat this process for as many wind definitions as we're going to need for your structure. Now that our wind definitions are created, we are ready to populate each of them with their code items to instruct STAAD.Pro to calculate our wind loads for us. We're going to first start with our windward wall in the X direction. We're going to highlight this wind definition that we created, and then click on the Add button in the Load and Definition dialog. Once we get to the Add New Load Definitions dialog, we're going to find a table for the intensity versus height. Currently, this table is empty, but we're going to go ahead and ask STAAD.Pro to fill this in for us by clicking on the Calculate As Per ASCE 7 button. Now, STAAD.Pro can be used to generate wind loads for the ASCE 7 specification by entering the type of structure, the surrounding terrain, and the wind direction. In this exercise, we're going to show you how to create that wind definition for the global X direction. The first thing we're going to do is we're going to enter our code version. For this training, we're going to use the ASCE 710. Next, we can enter our building classification category, our basic wind speed, the exposure of our structure, and the structure type. Now for this training, we will be generating wind loads for a building type of structure. Lastly, we can also consider wind speed up over hills or escarpments, and you can click yes or no if you do have topographic factors to be considered. Now for building structures, STAAD.Pro will calculate the wind loads according to the ASCE 710, Chapter 27, which is the wind loads for building structures, main wind force resisting system. This common information will be used to calculate the wind velocity pressure according to the ASCE 710 equation 27.3-1. Once we specify all of our common parameters, we're going to go ahead and click the Apply button before moving on to the next step. Now the next step is to go over into the panel over at the left-hand side of this dialog and select the next item, which is our main building data. Here you're going to enter your building dimensions. So we need to know our mean roof height, which for this case is 35 feet, the building length along the direction of wind, which is 60 feet for our structure, and the building length normal to the direction of the wind, which is 75 feet. Next, you're going to enter your building natural frequency. Now for this structure, we're going to assume a natural frequency of 2 Hertz, which would instruct STAAD.Pro that this should be classified as a rigid structure. Finally, we're going to enter our building damping ratio and our enclosure classification. Now the main building data will be used to calculate the design wind pressure according to the ASCE 710 section 27.4. Once we're done, we'll go ahead and click on the Apply button, and then we'll move to our final step, which is our building design pressure information. Here we're going to define the wall that we're generating wind load for, and we're going to specify the windward direction. In addition to that, you can also enter your gust factor, your C sub P factor, and your GCPI. Now you're going to notice that these fields are currently grayed out. This is because STAAD.Pro already calculated or considered what these parameters should be. If you would like to override that calculation, you can always select the checkbox and manually or hard code the factors in these areas and then recalculate your wind loads. Basically, what we've instructed STAAD.Pro to do is calculate our height versus intensity table, which it's already done. So we'll go ahead and click OK, and you can see here that that's been populated for you. Once you're done, we'll go ahead and click the Add button, and then we're going to be asked to enter the exposure. Now the wind exposures are a way to account for surfaces such as perforated mesh that are less than 100% solid with regard to the way that they collect wind. These kinds of surfaces can be accounted for by entering an exposure factor between 0 and 1.0 to represent the fraction of the surface that is solid and collects wind. Now, if you'd like to enter a factor here, you can feel free to do that, or if we skip this process and click Close, it's basically going to mean that exposure should not be considered and 100% of the windward wall should be considered a candidate for collecting wind. Now that we're done with the first wind definition, we're going to then proceed on for the rest of them. So we'll go ahead and populate the leeward and side walls. Now the majority of the parameters in the X direction are going to be the same until you get to that last page where you're going to specify which type of structure you're going to consider. So we'll go ahead and populate the leeward X next. And on this last page, we're going to make sure we select the leeward radio button and click Apply. And we'll repeat this process for the sidewalls. And the sidewalls, of course, we're going to select the sidewall radio button. Now that we've finished the wind load for the X direction, we're going to also populate the wind load for the Z direction. Now for this particular structure, I'm going to assume all of the parameters are the same whether I'm acting in the Z direction or the X direction. So the topography, the exposure, I'm assuming will be the same for each of these directions. The only thing that will be different is when I get to my main building data, the building length along the direction of the wind and the building length normal to the direction of wind would be different for now that we're looking at the Z direction. And that concludes the process for creating your wind definitions in STAAD.Pro.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.
Welcome to the Bentley Systems training course where we will show you how to generate wind loads for building structures in STAAD.Pro Connect Edition. In this video, we're going to show you how to apply your wind definitions to your model through your wind load cases. This will include the process of defining the wind load cases and then creating your wind load items to complete the process. The first step in applying our wind loads to our sample structure is to create our wind load cases. For our particular exercise, we are going to create 4 wind load cases to represent wind load acting on the structure in both the positive and negative X directions, along with the positive and negative Z directions. To create your new primary load cases to represent wind, we are going to go to the Loading tab in the ribbon toolbar and click on the primary load case icon. Here we can enter our title of our load case, and this first load case will represent wind load acting in the positive X direction on the building structure. Next, we're going to enter our loading type. We're going to make sure we select wind here. Now, the loading type is used to associate the load case with the code definitions of dead, live, or wind load. This type of association needs to be done in order to make use of STAAD.Pro's facility for automatically generating load combinations in accordance with the code. Once we're done, we'll go ahead and click the Add button, and then we'll keep populating as many wind load cases as you need for your sample structure. Once you're done creating all of your wind load cases, you can go ahead and click the Close button in the Create New Definitions, Load Cases, and Load Items dialog. Now it is up to you as the engineer to determine how many wind load cases you would need to apply to your sample structure. For our model, we're going to assume these 4 load cases will work. We are now ready to create our wind load items, and we're first going to focus on our first wind load case, which is our wind load in our positive X direction. So to begin, we're going to expand our definitions area, and then we're going to highlight our wind load positive X. Once we've done that, we'll go ahead and click on our Add button, and we'll find our wind load items in the left-hand pane of the Add New Load Items dialog. Now, the first thing we need to do is to select the type. Now, this is used to select the wind definition that corresponds to the direction and wall that is being defined. This will be used to generate the wind pressures. Now, we're working on the windward wall for wind load acting in the positive X direction for this first load item. And that corresponds to type 1. If we look over at our wind definitions, we have type 1 windward X. So we're going to go ahead and select that type. The next fields that we need to populate are the exposed surface and direction fields. These are used to select the direction of application of the wind load, either the X or Z horizontal directions, and to control the surface for which the loads will be applied. Now, we are working on the windward face here, so we're going to say the X direction, and we're going to give it a factor of +1. Now, the factor is used in conjunction with the exposed surface and direction. This value influences which surface of a structure receives the wind load. This value can also act as a linear multiplier on the applied loads. So if we get a factor of +1, that's going to tell the structure that the wall in the positive X direction for wind load acting in that direction will be considered. Next is the ranges fields. Now, these are used to define a three-dimensional zone for the wind load application. All members that have both end coordinates within the specified range are assumed to be candidates for defining a surface that may be loaded if that surface is exposed to wind. Now, for a structure such as ours that has a sloped roof, you may want to consider using the ranges field to have a little bit more control over the wall and how the wind load is applied to that windward wall. So we're going to go ahead and define our ranges. And for this one, we're going to define a Y range, and we're going to go from a minimum of 0 and a maximum of 30. Now, if you leave both the minimum and maximum set at 0, which is the default, it means that that range will not be considered. The last thing we need to do is specify the open structure checkbox. Now, if this option is unchecked, like we're going to do in this exercise, STAAD.Pro assumes that these structures are enclosed. It seeks out closed loops formed by framing members and then uses these loops to generate panels or closed surfaces based on the members in the ranges specified and the end joints. The area within each closed surface is determined, and the proportion of this area, or tributary area, for each node in the list is then calculated. Now, for this particular structure, we are going to assume that there is cladding on the building structure, and that's how wind loads are going to be applied. They're basically going to be applied to the cladding, and then a tributary area is going to be calculated, and then the appropriate point force is going to be applied at the nodes in that windward wall. So we're going to make sure that this option is unselected, which would be appropriate for that type of building configuration. Once we're done, we'll go ahead and click the Add button. And now you can see that we have our first wind load item for our wind load acting in the positive X direction. Now what you're going to want to do is consider the other walls for wind load acting in the positive X direction. And the next wall we want to consider is the leeward wall. Now, the type for the leeward wall is represented by wind definition number 2, leeward wall for wind acting in the X direction. And we need to tell the program that it's now a leeward wall. So we'll go ahead and select the -X leeward sidewall face option. Again, wind is acting in the positive X direction, so we're going to give it a factor of +1. We're going to go ahead and take a look at our ranges, and this time we're going to do a X range for a minimum and maximum of 60 feet. Again, the open structure checkbox is not appropriate for this structure. Once we're done, we'll go ahead and click the Add button. You can see we have another wind load item, all housed within the same wind load case. Lastly, to finish off this load case, we're going to add our 2 sidewalls. So sidewalls are represented by wind definition number 3. And this time we're going to do an exposed surface of -Z for the sidewall face. We're going to give it a +1, and for this side of the structure, we don't need to use the ranges option. We'll go ahead and click the Add button. which represents one sidewall. And then we'll also give it a factor of -1 to represent the other sidewall. Go ahead and click the Add button and then click Close. Now, after you've completed the process of creating your wind load items for your first wind load case, you should go through and just review each load items to ensure that the load arrows and the tributary areas are how you would have expected them to be generated. To do this, we'll go ahead and select the first wind load item. Now, when you have a wind load item selected, the load that it represents, its arrows are going to turn blue. Now, this wind load represents the wind load that will be applied in the windward wall when the wind is acting on the structure from the positive X direction. The hatched areas represent the tributary area that is used to calculate the point force for each node within the windward wall. Now, since this structure has a pitched roof, the ranges fields provide STAAD.Pro with additional information to help identify the extents of the windward wall. So we can select the first wind load item, which is the windward wall, and then we can select the leeward wall, and we have our two side walls. Now at this point, if you're satisfied with everything, you can go ahead and move on to the next wind load case. So we'll go ahead and highlight the wind load in the -X direction. We'll click the Add button, and then we're going to basically repeat this process, except this time modifying our factors field to tell the program that this load is acting now in the -X direction. So we're going to start with our wind load from our -X direction. We're going to assume that all the wind parameters in the -X direction and the positive X direction are the same. So we're still going to go with our wind definition for type 1, but this time we're going to give it a factor of -1. This basically means, if I can pull this off to the side, that this wall will now be defined as the windward wall. Again, I'm going to use my ranges field to help the program identify that wall. Now, this might be necessary for things such as atypical framing when you have a sloped roof like we do, or any type of other structure that isn't completely boxy. This ranges field might assist you in applying your wind loads. So we have our first wind load item, then we're going to go with our leeward wall. Again, factor of -1. And our two side walls. Then if I go ahead and highlight these, again, now I can see my windward wall, my leeward wall, and my two side walls. Moving on, now we're going to also populate our wind load in our Z direction. So again, we start by highlighting our load case, and then click the Add button, and then finding your wind load item down here. Now this time we're going to use load types 4, 5, and 6. So the first thing we're going to do is select load type number 4. This will represent wind load acting in the Z direction. So I need to change this toggle for the Z windward face. We're going to give it a +1, and then we'll go ahead and click Add. So I have my windward wall. Next, we're going to do our leeward wall for wind load acting in the Z direction. So I'm going to select the Z leeward wall option. And then I need to populate my two side walls. This time I'm going to do the -X sidewall face. And the -1. And then to complete this process, we're going to populate our last wind load case. Now, after we're done, you can also review your load arrows for these additional load cases for the Z direction just by clicking on them as we had done in the X direction. So here I have my wind load acting in the positive Z direction. So here's my windward wall. There's my leeward wall. And I have my two side walls. Then wind load acting in the negative Z direction. There's my windward wall, my leeward wall, and then again my two side walls. Now the last thing we're going to discuss in this training course is to take a look at the wind loads that have been applied to your structure. Now you as the engineer would be responsible for determining which wind loads need to be applied on your structure and to make sure that they effectively get applied appropriately. Now for this particular structure, we're going to notice that we were able to utilize the wind definitions to apply basically a pressure along each wall. That pressure is then calculated by the tributary, multiplied by the tributary area, represented by this hatched area, and then applied to the model at the nodes with point forces. Now, if this represents all of your wind loads that are acting on your structure, you may be considered done at this point. But if there's anything else you need to consider, you may need to apply some additional load items to your model. Say, for example, you have some type of antenna or additional structure on your model, or basically on your building structure, but didn't make it into your STAAD.Pro model. Well, if that particular item is collecting wind load, then you're going to want to be able to add some additional wind load items to represent that load and get it into the model. Now for this particular structure, we're going to assume that there's also some uplift forces for your main wind force resisting system acting on your joists at the roof level. So I'm going to add that as an additional load within each load case to ensure that it's also being considered. To do that, you're going to add that just as you would any other traditional load item. We're going to highlight our wind load case and then click our Add button. And then you can use any of these load items to represent the additional wind load that you might need. So say, for example, I'm going to use member loads in a uniform force for this model. I'm going to select that, and then I'm going to enter my magnitude of my force. Now for this particular case, we're going to need to calculate what this load is by hand, as the wind definitions will take care of wall forces. We need to calculate this as an additional item. So we're going to enter the direction for which it's going to be applied, and then we'll go ahead and click the Add button and then close. And then you can see we have our uniform force here. Now I've went ahead and set up a group for this particular model to represent your roof members. So I'm going to highlight this wind load item, and I'm going to say Group Selection. Now this is available in the Geometry tab of the ribbon toolbar. And we're going to select the roof and then click Close. And then we're just going to say Assign to Selected Members. And now we've gone ahead and assigned some additional load. And you can use this to represent any other type of load that doesn't get calculated through the wind definitions, but still should be considered in the analysis. And we can repeat that process for the additional wind load cases as needed. At this point, this completes our process for applying wind loads according to the main wind force resisting system for building structures in STAAD.Pro.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time. If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.